Okay, this is problem number 4 on the sample test that I posted for you for summer of 19. It's a very simple problem. It's parameterizing an assembly. An assembly is made of these two parts, and the parameters are this angle alpha, the radius. This is actually part of a sphere, because notice what it says: AB is equal to AC is equal to AT. That should give you a message that actually this is a sphere, or at least part of a sphere. So the radius of the sphere, or that distance, think about it like that, and the L, the size of the box. And notice it says the three edges are equal size, so this should be a cube. Okay, so let me go ahead and create two parts, large and small, and then we put it together. Okay, we start with a product. Immediately save it. File, save management, save as, desktop, new folder. I'll say question 4, sample midterm summer 19. So that should be question. Okay. There are different ways of doing these problems. Okay, so let me go ahead to assembly design. First, I'm going to make the nominal parts. So insert, new part, in there. Let me call this thing the big one, large one. Properties, large. And large, that's the big cube. Large. Okay, good. Let's make it. So it's just a box. Yeah. So a rectangle. And I'm going to dimension this. Yeah. Because eventually these sides are all going to be equal. Exit. And then pad it. And I don't know, opposite direction, I suppose. And let's go to around maybe 4 or something. Very good. Okay. So then I'm going to create a semicircle here, or quarter of a circle on that face, and then shaft it. But actually, because I want to remove material, I don't want to shaft it. I can do a groove. Okay, so let's try it. On that face, I will sketch. Okay, so let's make sure we do this thing right. So here it is. We're going to clean it up in a minute. Okay, and there we are. Okay, and then the circle. Clean it up. What do I mean by cleaning it up? So quick trim. Let's get rid of this, and get rid of that, and get rid of this. Okay, and then we make this point coincident with that point. There we are. Okay, so let me dimension this fellow. This is going to be eventually my R, right? Yeah, it's that distance, and that is your R. So exit. Now, if I shaft this, it obviously creates a material. What I would like to do is I want to actually groove this. The groove is right there. And I don't want to go 360. Let's go 45 degrees for now. This is going to be one of the parameters that we're going to be using. And this is about the z-axis. Oh, wait a minute. What happened here? Okay, the axis, I wanted the, this is not the right axis though. Cancel. Not the z-axis. I wanted to select this axis. Let me see, can I undo this? No, I don't want to create a line. Sorry. About a actually, I don't want to create a line. I want to select this line. So okay, so let's cancel that. Let's see. I want to use this line for shafting purposes. Okay, so let's see now. Let's try not shaft, groove. Okay, so let's make sure this is 45. Okay, profile is this. Okay, and the axis is this line. That's what I wanted to do, but in the other direction. And right now it's 45 degrees. Eventually we're going to make that thing a parameter. There we are. There we are. Okay, we just look just like that. Okay, so save everything. And then we're going to insert the small one. So insert, new part. We're going to call it the small. Right click properties, small, and small. Okay, let's make it. It's exactly the same thing as that. Okay, so on a convenient plane, on that vertical plane, I will sketch. Alright, how about doing exactly the same thing that we did before? We're going to match it later on. Right now, dimensions don't have to be the same, so we just draw whatever we like and clean it up. Okay, again, quick trim. Get rid of this, and that, and that. And dimension the circle. Remember, it's going to be the same as the other one. It's going to be what we call R later on. Exit, and now shaft it. So read this thing carefully. So for now, I'm going to make it 45 degrees, but later on it's going to be a parameter, and it's going to be shafted about this axis. Okay, and just to make it look good, reverse direction. So this is going to fit in there. All right. So actually, let me change the color of this. Properties. Let me change it to yellow. Okay, good. Now, save everything. This is parameterizing an assembly. We already know that we have to create 4 parameters at the assembly level. You have to make sure you're there, right there. So you say f of x. Okay, f of x. So 2 of them are length, 1 is the angle. First one, call it big L. Give it a value, maybe 4 inches. That's this height. Okay. Another one, big R. That's going to be the radius of that circle. Big R. So for now, I'm going to make it, I don't know, 1, for example. Apply. And I want an angle alpha. Click on it. Alpha. Let's make it 45 degrees. Later on, we're going to change it. Right now, it's 45. And apply. Now, notice that we have the 4 parameters created at the assembly level, and they have nothing to do with our model yet. So now we're going to make the appropriate correspondence. So we go to f of x. Okay, let's click on that. This is going to be L. The height, this height is going to be L. Add a formula equal to L. This is going to be L. Add a formula. Rename parameter L. The pad, this is 4.78. Add a formula. Rename parameter equal to L. Okay, good. Now, if I click on the large part, I want to get this sketch. Remember, I drew a sketch here and then do the groove. So if I click on the large one, there is the radius of the. Which one is the radius? I think this is the radius. Add the formula. Rename parameter R. Okay. And how about the angle? There's the angle right there. As you can see, 45 degrees. You select this, add a formula, rename parameter alpha, and then we're going to do it with this part. Okay, so this is going to be your R, add a formula, rename parameter R, and where's my angle? There's the angle, you can see that right there. Add a formula, rename parameter alpha. Okay, and close it. Now, when we change these things, these should change accordingly. In fact, if I say update, look, same size. L is this size of the box, so let's make it 3. Of course, it's not going to affect that wedge. It's going to stay the same. Let's take the 45 degrees and make it, I don't know, 90 degrees. Both are going to change. There we are. You can see that. And R is the radius of that, I don't know, portion of the sphere. So we make it 2. They're both going to change. Now, if you don't want to lose any marks, make sure the assembly constraints are respected. In other words, once you update, these should go back to where they are. So let's do some assembly constraints here. For example, this edge and that edge, and this face and that face, and just to make sure this face and that face, and update. Okay. Now, if you move things around in a very weird way, there we are, there we are, there you are. When I update, they should snap back. How they do? Full mark. Okay. Assembly constraints must hold. That's what this thing is. All right, folks. So I did the second problem for you.